Thank you very much indeed. And requesting everybody to kindly remain seated as we straightaway move to the next session. Sustainable space operations, which require robust tools and practices such as space situational awareness, SSA, space traffic management, STM, and debris mitigation and conjunction analysis and mitigation. These measures ensure the safety of spacecraft, prevent collisions, and minimize space debris. Collaborations between public and private entities, innovative business models, and responsible practices are crucial for achieving sustainability in the space sector. And ladies and gentlemen, in this session, I would like to invite our chair and moderator, Mr. Stephane Chenard. A warm welcome to you, sir. He's a senior consultant, Euroconsult.
Thank you very much. If my panelists could...
I would like to invite them, sir, with your permission. And eminent speakers are Mr. Navin Gopal, Vice President of Strategy and Business Analysis, Astroscale. Warm welcome to you, sir. And Dr. Rachit, Bhatia, Space Safety Analytics and Research Lead, LeoLABS. A very warm welcome. And I would now hand over to our chair and moderator, Mr. Stephane Chenard. Over to you, sir, and the time duration you have is about 35 minutes. Is that okay with you?
Thank you very much. Yes, that should be enough time. Ladies and gentlemen, we're going to help conclude this conference by talking about the garbage and the ways to remove it from space. So, we have two companies here in a field which used to be purely government-driven with military sensors pretty much doing all the job. Now it's increasingly privatized and as it's attracting a huge amount of industry interest and concern, given the volume of debris, the tenfold increase, I think, in the risk of collisions in the past 10 years, according to the European Space Agency. So we have two companies, LeoLABS, which is watching the scene with its own array of sensors, and Astroscale, whose ambition is to remove the aggravating objects. Okay, why don't you take 8 to 10 minutes each to describe what you're doing, what your plans are, how you see the situation. So.
So I'm here from LeoLABS.
Closer to the microphone.
Can you hear me? Okay. I'm here from LeoLABS, California, and we are a global SSA, SDA provider, space situational awareness and space domain awareness service provider, and we have ground-based radars all around the globe that we use to track objects in low Earth orbit. We are providing services to at least 60% operational satellites in low Earth orbit. We track everything between 200 and 2,000 kilometer altitude. And we have 10 radars and 6 radar sites around the globe. And we have these phased array radars, which we build, deploy ourselves. And our plan is to build a global network of ground-based radars so that we can track everything at frequency sufficient enough to provide real-time SSA, which is seamless and enable space behavior awareness at scale. And we are doing sensor fusion from all these radars that we have around the globe, and we provide these services to our customers. So what do we mean when we say space behavior awareness at scale? Our goal is to, and this is something that we are pretty much already doing with our 10 radars, because we are tracking all these 20,000, 21,000 objects in low Earth orbit. We are looking at all these objects and making sure that the conjunctions that they are encountering are alerted to the operator in near real time. We provide analytics to them so that they can plan their mission ahead accordingly. And then we also do risk assessment, both empirical risk assessment and statistical risk assessment for operators in low Earth orbit, so that we can keep the operations in space safe and secure. So what is our differentiator from what is available in the market is that we have our own sensors, and we are generating our own data, and then we are providing these analytics. So it's an end-to-end service that we are providing and enabling for the user, which leaves little to no confusion because we are very transparent. This data is available 24/7. We share measurements, we share the biases, the noise that is there on our measurement. We share the uncertainty on position, velocity of these objects, so that the operator can know and differentiate the data that they are receiving, how good it is, and be able to make a decision when in real time when they're encountering a conjunction ahead. And that is the goal. We are already working with companies like SpaceX, OneWeb, and they are using us right now in operations. So that is something that we are looking at, and that is something that is needed for as we go forward, because the way the systems are increasing, more and more companies are operating in low Earth orbit. We are looking at a population that will grow up to 50,000 objects soon, and there will be multiple 10,000s of operational satellites. So back in 2019, there were very few operational satellites, less than 1,000, and today there are 7,000 and counting active satellites. So we need scalable, we need reliable, we need transparent solutions to make sure that we have a resilient SSA, and commercial SSA provider like LeoLABS can help with that. And we are not here to compete with national systems. We are here to augment national system, national and defense system, so that there can be a best of both worlds, because there's definitely a need for indigenous systems, but with the way this LEO environment works specifically, because all of these objects, remember, these are traveling at a very fast speed, 12 kilometers per second. So we want to make sure that these are being tracked, and the best way to track them are using radars on ground, and a global system is always required. So even if we have sufficient sensors in a country at a particular location, it will not be sufficient to meet the SSA requirement that will be needed to support any system. So global SSA is always required, and that is what we are trying to provide in all different countries. We are already there in USA, we are there in Australia, we are there in Japan, and we are looking in India. We have a reseller here in Delhi, and we are in talks with different agencies so that we can provide our solutions to customers here. Thank you.
Rachit, how scared would we be if we saw everything that you see on your radars? Occasionally, we hear of a conjunction that was especially close. Occasionally, your company, other companies report on inspector satellites having maneuvered in a way that is possibly dangerous. Is there a lot of these incidents that never see the light of day, or how much is going on up there, really?
Yes, so we are tracking all these conjunctions, and we are analyzing all these conjunctions. And because we have this capability to not just give real-time alerts, but also record them and analyze later, we have this huge repository that we are looking at, and we are able to compare what is the main problem right now, what will be the problem in future. We have there are two segments of the problem. There's space traffic management between operational satellites, and then there's space debris management, where there are satellites which are derelicts, which cannot move anymore, or which are debris, paint chips, etc., which are being tracked. They cannot move, they cannot maneuver. But we still need to avoid them, because if they will collide with operational satellites, then operational satellites will stop working. So there's space debris management, space traffic management. What we are seeing at some particular altitudes, like 800 to 900 kilometer altitude, there are huge rocket bodies which are there from cold space era, which are Russian rocket bodies, school bus size, thousands of kilograms, and these rocket bodies are tumbling and are not able to maneuver, and if anyone operating in the vicinity, they have to avoid them, right? So these have huge debris generation potential. If anything collides with these, even a debris collides with these rocket bodies, there will be huge, more debris being generated, right? So we are tracking those, and we are seeing these rocket bodies going past each other and having conjunctions within few tens of meters.
Okay, so huge rocket bodies tumbling in the dark. I don't know if you guys coordinated. This is such a perfect transition to what you have to tell us, Navin.
What a wonderful segue. So let me tell you a bit about Astroscale before I tell you about me. Astroscale is a space sustainability company. And I'm not going to beat a dead dog deader. I mean, everybody knows what space sustainability is by now. We just talked about how busy the LEO orbits are, not just with active satellites, but more so with really large debris. Astroscale's primary function and our raison d'etre is to ensure that space remains accessible and safe for future generations. And we do that through 4 mission lines. One is the prepared end-of-life deorbiting of satellites. What that means is we put on a docking plate onto a satellite when it's on ground, launched with a docking plate. If it's beleaguered in orbit, we can use a ferromagnetic capture mechanism, grab that satellite, deorbit it. And that capture mechanism, the docking plate, is vendor agnostic. We built it with sustainability in mind, so it's not something that you have to come back to Astroscale for. You can go to any other vendor that has ferromagnetic capture capability. The goal here is to ensure that everything that's launched into LEO can be deorbited easily if it ever is beleaguered. The second mission line we provide is in situ SSA. So LeoLABS does it from the ground, uses radars to look at a lot of the stuff out there, gather all that data, build models around it. We take a different view. So we are space on space, looking at and categorizing objects in space. And that can be done on multiple levels. You can do it on a resolved imagery level, where we look at an object specifically, categorize, map its tumble rate, material degradation, material condition, a state of the other aspects of that object that you're looking at. We can also do uncategorized imagery, look at a large area, determine risk of that space with regards to both intrusion and also collision risk, etc. And in order to prove these capabilities, within the next few months, we are launching a mission called the ADRAS-J in collaboration with JAXA, where we're going to look at, categorize, map, and create a plan for deorbiting for a 3-ton rocket body in low Earth orbit. And that's what we're talking about here, the really high-risk objects. And the third sort of mission line that we do is active debris removal. And active debris removal are objects that are not prepared for deorbit. So you can't use a simple ferromagnetic plate to capture it and deorbit it. You need to do something a bit more robust and complex, robotic arms, stuff like that to grapple it. And that's the follow-on mission that we're working on with JAXA. That will be somewhere in the horizon of 2025, where we will look to go and grab that object that we have categorized, and deorbit it. So it's a very large object, 3 tons. The fourth mission line that we do for sustainable space activity is in GEO, which is life extension of GEO satellites. Trying to life extend in LEO satellites is very complex, and I think we'll talk about it at some point in the conversation. But in GEO, because of orbital dynamics being less a part of how things move in that orbit, we are able to grapple very large satellites up to about 4 tons dry. So if you're looking at launching a 6-ton wet satellite, by the time it comes to its end of life, it's about 4 tons. We can deal with it. Grab it, hold it in station, even adjust its inclination if it has inclined or declined over time, bring it back to its proper orbit, and extend its life over a given space of time. We are looking at extending that capability of third-party life extension. We grab a satellite and life extending it to the ability to refuel. So we are also in the process, through collaboration, to expand that capability to refueling into the future. Of course, we can't do it right now because none of the satellites that are in orbit right now, well, almost none of the satellites that are in orbit right now have refueling caps, so you can't really refuel them. But that is the other thing that we're looking forward to. The sustainability aspect of space improves when satellites can be refueled. So we do all of these things for sustainability because we are in trouble right now with what's out there. We need to make it safer than it is. And my fellow panelists pointed out, we're going to put a lot more satellites out there. 50,000 will be the holding cap. In order to get to 50,000, we need to launch about 70,000 odd satellites over the next decade. There are already 40,000 pieces of garbage in space, large garbage, from the size of a grapefruit to 3 tons, 4 tons. We're going to add 70,000 more of those. In an environment of 100,000 pieces of these objects in low Earth orbit, they take time to deorbit some of them take very long time. We are going to be in even more trouble if we do not have solutions to think about the post-life treatment of these operational assets and systems. And we are here to do that today with the further on goal of extending to a circular economy process, which I hope to be able to talk about later as well.
Okay, so let's, the second line of business that you mentioned, which is capturing non-cooperative debris, which seems to be the one that's the most relevant to to cleaning up space, to speak simply. And you said the demonstration for that is coming around 2025. The issue there, I guess, is one of economics. It's a little bit like building a garbage truck every time you see a fridge abandoned on a sidewalk and then throwing away the garbage truck. Is it possible to capture multiple objects in a row and then deorbit them, make your vehicle reusable? Because otherwise, I don't know how much an Astroscale deorbit vehicle costs, but it's probably too substantial to deal with every large rocket body tumbling in the dark, as we heard before.
Absolutely. And the goal is to deorbit multiple objects. We're looking at it in multiple forms. So when you look at an object, you have to think about how do you grapple it, what's the space available for you to grapple an object, the size. And if you...
And how do you grapple it, by the way? A lasso, a net, or does it work?
So for a first process, we're using a robotic arm to grapple it. As we get into more complex environments, we are now exploring a dual grappling arm process. And again, the complexity of dual grappling arms.
Like kind of bear hug.
Grab and maybe even bear hug. So there needs to be variability because as you know, there's still limited standardization in space. How you deal with an object in space requires flexibility. So you may need one arm that grapples very traditionally like a fist, one arm that maybe loops, and we're exploring all those capabilities for very complex objects. For now, we've discovered that a lot of objects can be grappled with one arm, especially the really large ones that are in relatively good nick, and you can deorbit them. The challenge also, to your point, is these are very government to government. Does one government in a contract have 3 or 4 of these sort of similar objects for you to deorbit, or do you need to find a collaboration between governments in order to address that, which is, again, how this
Well, I guess you do, because a lot of those tumbling objects have Soviet flags on them. And so, as the law is structured today, you need the other country's consent to go and play with their debris, which they may or may not give.
Absolutely. And it will require government-to-government collaboration in this matter.
Are we moving in that direction? Is any progress made?
Yes. In Europe, you see that very clearly, but it's natural to Europe because of ESA holding a wider berth on it. But you're also starting to see conversations and collaboration between European institutions and Japan in trying to address this together. And I think these sort of forward traction down that path will help.
How about the Russians and the Chinese?
Well, there comes a point where that also has to be decided. We cannot act without the Russian and Chinese being on board. We need to figure out what is that middle point that everybody agrees on, take the steps forward, but yeah, it has to be a global move. Or we only remove part of the problem.
Can I add?
Of course.
I also want to mention that LSAD technical demo by Astroscale, we were part of it, right? We are looking forward to enabling what Astroscale, ClearSpace, and others who are interested in ADR are trying to do, because we can clearly see ADR is only the way forward. If we will not remove these large rocket bodies and debris generating potential objects, then it will be very difficult. And that is why using our data analytics for last 2 years, we have been publishing 50 most dangerous objects in low Earth orbit, so that whoever is working on this technology can target some of these most dangerous objects which are experiencing the most number of conjunctions and have them and pose the greatest risk in to the environment.
Okay, I could counter. You say those are the most dangerous objects. They've been around a long time. Occasionally there's one of them that does go boom because some fuel had been left inside and it corrodes and that stuff happens. The greater part of the risk to come is those thousands and thousands of additional satellites that are being launched. And the industry is taking some measures to ensure that they don't cause too much additional risk. So we'll drill into that. What's the smallest you can detect today with your network?
So our radars are designed to detect and track sub 10 centimeter objects. Right now, we are working on cataloging these sub 10 centimeter objects. We are already cataloging and providing real-time data on all the objects in public catalog that is 10 centimeter or more.
Okay, the US Air Force can do 2 centimeters. I think that's their limit.
Sorry, say
The
again?
US Air Force can do 2 centimeters.
They do have this space fence, which has a capability of doing sub 10 centimeter. I'm not sure if they have demonstrated 2 centimeters specifically, but they do have a capability to do that. At the very recent, when I checked, they have published around 2,000 objects, which is far less than what they were anticipating to do, because Space Fence, remember, is a project which took multiple decades and billions of dollars to build. So,
but at some point anyway, if you have a catalog of the millions and millions of centimeter scale objects that are up there, what are you going to do with this? You'll have thousands of potential conjunctions per day, and even today, a lot of the conjunctions are not acted upon, or too late, because it's too many.
Yes, so what we are seeing, because we work with all these large constellations like SpaceX, etc., they have been very responsible actors, and that is where we disagree in terms of like what we have seen in terms of these operational satellites. They are not a problem; they are a victim right now. there can be a focus on space traffic management in the future if the number continues to grow. But right now, the number that we are seeing and how they are operating when these constellations are working in sync with all these satellites and maintaining their shell configuration, it's actually tremendous technology that they have demonstrated, and we don't see any problem with that. The problem is when you have derelicts come into play, these objects which cannot maneuver. So I think there has to be knowledge about what is out there, because if you do not have information of what is out there, then first of all, it defeats the purpose. So SSA, first principle is to know what is out there. The second principle is to plan how to mitigate it.
Oh, information is good. I'll be the last to deny that. The Starlink has those maneuverable satellites with this AI-based system that they say allows them to dodge the threat. They have not provided a lot of detail about this, but it seems to work. I'm sure you watch them keenly, and does it seem to work to you also?
Yes, they are ingesting our data. They ingest our conjunction data messages, and they use it real time on all the satellites. And they have recently published their data as to how many conjunctions they did over the last 1 year, and they have tried to bring some transparency, and they have done these MOUs with other companies like OneWeb, etc., and they have an MOU with NASA as well. Of course, I mean, you will have to talk to SpaceX of what their exact policies are, but they are working on these policies where they have clear rules of the road. They are not looking at who will maneuver. They are deciding that if there's a conjunction between Starlink and NASA satellite, NOAA satellite, then Starlink will always move. And
but this is where eyes on the target that you guys provide is critical, because the oil industry can tell me that they had no incident last month. I don't believe them for a second, because we've seen them at work. Big companies that have the potential to pollute are going to lie if they pollute. They're going to cover it up. It's human nature.
True, but that is where we come in. We are tracking everything, right?
Absolutely. Navin.
So, I also have another perspective on this. Yeah, the objects that are derelict in space are the main concern right now. One, because they're large.
That's reassuring.
And yeah, which is scary. The thing is, the stuff that's being launched into space is also a problem. And the reason is, yeah, the example of Starlink, they have acted very responsibly. At the same time, they sit in an orbital shell that's very close to Earth, that allows for the natural decay of those post operations to fit within the 5-year recommended span. But we have a lot more constellations that sit much higher. And as we launch newer constellations, because it's crowded down low, you're going to have to start looking at business cases that sit much higher.
And CubeSats, how much should we be concerned about CubeSats?
Very concerned about CubeSats, because you can't prepare them for deorbit. And they're small, so we think small is fine, but they're still big enough to be dangerous. We'll get to that in a second, and I think the important thing to think about is, you launch 70,000 satellites. We've tracked failure rates of new launches over their lifespan around 2 to 7.5%. Let's take a conservative view of 2%. 70,000 satellites, we're talking about 1,400, 1,500 satellites derelict over the next 10 years. Those satellites need to be addressed. If they don't have a prepared form for them to be deorbited by a third party, they add to that pool that LeoLAB now has to track and worry about and have to kind of plan out for. So we also have to think about both aspects of the garbage in space. That which is already there, we need to clear up, and we need to stop adding to it in a way that's damaging. So I think that balance is critical. And to address this, the issue of really small satellites, the micros, there are two challenges. One is a question of orbital height. Where do they sit in the orbit? Anything that's less than 400 kilometers is very hard to address. if there's something goes wrong, the satellite has to kind of deal with it itself.
It will decay, right?
It decay quickly, yes, but decay unpredictably, which is a challenge. And if it sits higher than that, they'll take a very long time to decay. And if something goes wrong and they're beleaguered, we can't grab them, because the solution, in order for them to be prepared, may even be larger than the satellite itself. So that makes it a threat to have to think about. And we need to figure out how we balance the utility of these really small micros with the benefits they create.
Well, yeah, but message to anyone from the previous session on space education and so on. I think personally CubeSats look to be a lot of fun. Every time one of those little things, which sometimes we don't know that they've been launched until weeks after the event in a tweet, the Air Force says, I never knew about those guys, and they're launched for educational purposes. They feel a little bit like a bicycle on a highway to me, and I would really caution some of those educational and scientific and CubeSat teams to think if there is not a potentially less hazardous way of doing what they want to do than letting go 3 kilos of equipment in the same orbit as the space station with no way to identify or to maneuver.
Actually, Stephane, if I can be a bit more cynical, it's equivalent to cannonballs in a freeway, because they're very dangerous. It's not the danger to them alone, they're dangerous to the other vehicles.
Rachit, I want to open the floor, by the way. Anyone in the audience who wants to chime in?
Before we do that, can I just add one last point to how the cataloging is a problem? That is why where LeoLABS is coming in, we have done these missions where when transporter mission is being launched, right, hundreds of satellites, those take weeks to catalog. But we are working with these operators, small satellite operators, to actually have the signal acquisition just 1 or 2 days after the launch. So that is one of the things that are needed for the community, because if we will take, as you said, if it will take weeks to catalog, then you cannot ensure safety of that particular satellite and any other object in the vicinity.
Clearly not, and I don't know how many of them pick the phone when you call them. Since we are on that, by the way, in a lot of the data on which the community relies, I'm scanning the room to see if there is any raised hand, a lot of the data on which the community relies for tracking, apart from yours, your data are paywalled, right? By the way, the free data are from the US Space Command. That data is not necessarily going to be available to the public indefinitely. There's a piece of regulation in the US, Space Directive number 3, which says at some point DoD is not obligated to publish that stuff anymore, in which case we become half blind. We become essentially entirely reliant on companies like you. So for you catching, it's a big opportunity. How are you going to deal with that when that sunset happens?
So to answer that, you said paywalled, right? So
you're not a charity.
Right. And I mean, it should not be, because otherwise you will not be able to provide state-of-the-art solution, right? So to provide state-of-the-art solution, you have to be in business. And that is how we are able to build these radars. These are not cheap sensors to be built and being deployed around the globe. So that is the idea. Now, that is why at the very start of my address, I said we are already working with 60% operational satellites, at least, right? So we are already covering 60% of the operational satellites which will need our solution. And that is why we are reaching out to these small satellites and providing these small satellite operators who are launching on transporter mission and other missions some service along with the launch provider. So this is at no cost to the operator. This is in package with their deal with the SpaceX on transporter mission, that we provide them the service for first 2 weeks where they can get cataloged, do signal acquisition, because of the same reason, because we understand the criticality of it, right? And that is why we are also coming into Indian market, other emerging markets, because we want to make people aware about this problem and want to work with the government with the national agencies, defense agencies, to solve this problem in an agnostic and reliable way, sustainable way, because otherwise, if it will be a charity, then I don't think anyone will be able to provide state-of-the-art solution.
And we have a question in the back, sir.
Yeah, my question is, how accurately can you determine to whom the space debris belongs to?
Yes, this is part of object characterization. This is another thing that we are doing, and we are enabling with our data that we are collecting, and we can. It is difficult to put a number like how accurate when we are tracking 21,000 objects. Out of those, around 14,000, 13,000 are debris, and out of those, some of those are big clouds where you can clearly say, based on the orbit, those are from the Fengyun 1C anti-satellite test back in 2007 by China, or this particular debris is from 2019 Russian ASAT test. So that is already possible. But in the meantime, there are some objects which are lost. For example, the most recent report is like 28 objects from Cosmos 1408 were lost from the catalog because there were no updates, or it was not sure, we were not sure if it was decayed, etc. And we are right now tied up to the public catalog, so it becomes tricky, but we are making sure that we become independent and we are able to provide characterization of these objects as well. So that is one of the things that we are looking at. Another important statistic is that Cosmos 1408 happened around at a very low altitude, right? 450 kilometers, etc. And so majority of the cloud decayed even before it could be cataloged. So we want to prevent that. We want to make sure that we are able to catalog each object in time so that we know where these objects are going and what risk they are posing to the environment.
From those two tests, or from others that may perhaps have also taken place. Another question here.
Stephane, Tom Carroll with Space Logistics. Stephane, you know my background. So the derelict debris that you were talking about, is someone willing to pay for that to be removed first? And then the second is, because of my background, I know that they're greater than 3 meters in diameter, and the fuel tanks are external to the devices. So any type of grabbing or, as you were talking, bear hugging, you'll rupture the tanks, and if they have not been pacified, you will have an explosion with hypergolic fuels. So it will be a self-destruction of your own vehicle.
Good
so
point.
the real question, one is the concern about touching one of those derelicts, but do you have, and getting permission, but who's going to pay for that? Are you going to do that out of the benefit of your investors to?
Yeah, so I'll answer that in reverse. So the second one, we're starting to see governments willing to spend on it. JAXA being one example. The mission that's launching in the next few months, we'll kind of answer question number one, which is to look at the object, categorize it, figure out how you would grapple it. We already have design specifications before we launch to kind of understand what are the basic premises, but we want to see what the state of the object is before we actually design that final solution. So you're right. There are complications to it. It is not as simple as going up there and you know, grabbing something and just throwing it away. But from what we've seen thus far, and again, the mission end of this year, early next year will confirm, is how we would do it. Also back to the second question, we're seeing similar moves towards funding these sort of processes in the UK via missions such as the COSMIC. ESA's got you know, missions that are trying to get debris out of, or large objects out of the orbit. Governments are starting to take responsibility for these objects with the realization that you need to get the orbits clear for the space economy to grow. Where all of this keeps rolling on to, we still have to see, but we're already seeing the interest down that path. And again, you know, we've seen language come out of the US Space Force, NASA, pushing the US government down that direction, or the sort of the US market down that direction. And I think it's a matter of time before the US also engages actively in the way that Europe and Japan has.
And with that, I think we've run out of time. I trust we touched on all the important points. Yes? Anything to add? Or a really quick one then, please, because our host is closing in already.
Thank you for the opportunity. Just wanted to add to the previous question. What could be the potential funder or the collaborations if someone wants to solve the problem of debris removal from the orbit? Like, how should they approach, especially in this startup scenario and especially in the Indian scenario?
In a word.
Thank you.
Potential for cooperation?
Well, you're not gonna solve these problems alone. So the way Astroscale views it is we want to collaborate. We do a lot of collaborations with LeoLABS. The LCD mission is a start. We intend to do a lot more things with them because we can't do everything. We have part of a solution. So we talked about the single arm grappling capability. Because it's very correctly pointed out, it's very complex to grab a object that you're not very sure how sensitive it is to being grabbed. We are doing collaboration work, research and development work with organizations in Asia Pacific and around the world around a second grappling arm and that possibility and how would that work. We're looking at things like soft end effectors, things that can hold with good amount of force yet still be delicate on the object it holds, etc. And a bunch of other things. So we continuously look to collaborate in order to expand our capability to deliver value. So yeah, absolutely. In whatever you have as a thought process, an idea, as a solution, we're interested to hear that.
Okay. So thank you very much for being with us today. Thank you.
Thank you.
Thank you very much
Thank
indeed,
you.
sir. And ladies and gentlemen, we close the proceedings of this session, inviting everybody to kindly join us for tea. And the next session, which is a plenary session, also the closing session of this 3-day India Space Congress 2023 will commence from 4:15 p.m. onwards. We would request everybody to be seated by then. Thank you. Please enjoy your cup of tea and coffee and be back in time for the closing session. Thank you.